G.fast retransmission, principle and parameters. Last time, we've talked about definition and purpose of G.fast retransmission. How does G.fast retransmission work? Here, we take the downstream direction as an example to show you the principle of G.fast retransmission, contrasting with that in the upstream direction. As shown in the figure, both the transmitter and receiver provide retransmission queues. The transmitter encodes data to be transmitted to data transfer units. After transmission, the DTUs are cached in transmitter retransmission queue. The receiver receives the DTUs sent by the transmitter and caches them in a receiver retransmission queue. Then, the receiver checks for errors. If the receiver detects data errors in DTU, it will request a retransmission from the transmitter. The transmitter retransmits the DTU upon receiving the request. The receiver checks the retransmitted DTU after receiving it. If the data is correct, the receiver sends a NAC message. The retransmission ends. The whole process is quite simple. However, we have to get some parameters to control and adjust the retransmission. We've introduced a single high-end pulse noise event, which is unpredictable. While shopping online, a shop owner can't predict whether goods will be damaged during transportation. What they can do based on their experience is to take proactive measures for goods delivered to regions that experience a high damage probability. Remember, shine is an unexpected impulse noise event. We can set values of the minimum IMP against shine in symbol periods and ratio of shine in line based on historical data. Repetitive electric impulse noise is generated continuously and repeatedly. When the goods are delivered, some damages from jolts and slight collisions are inevitable. The shop owner usually bubble wraps the package to prevent damage. We can set values of the minimum IMP against rain in symbol periods and frequency of rain. The first time the goods are broken, the shop owner agrees to send another. However, if it breaks a second time, both you and the shop owner may want to cancel the order. That's to say, the retransmission won't happen infinitely. After a certain number of retransmissions, if errors persist in the DTU, the retransmission stops. The parameter delay max, indicating the maximum retransmission delay of G.fast, defines a valid retransmission period. During this period, if the receiver doesn't receive a correct DTU, the system will abandon this DTU and a bit error occurs. Redelivering goods costs the shop owner too much money. So if goods are slightly damaged, the shop owner will try to negotiate with you by refunding some of your money. Avoiding redelivery will thereby reduce costs. Retransmission for G.fast works the same. The last retransmission parameter we have to set is ratio minimum. This parameter indicates the minimum forward error correction code word redundancy ratio. This parameter defines the minimum error correction ability of each FEC code word. As if saying, FEC can correct the minor errors with its redundancy ratio, so don't retransmit the DTU. So we've learned all the parameters for G.fast retransmission. After software configuration, these parameters are issued to the chips. The chips then calculate the actual parameter values based on its capability, line rate, noise, and other factors to provide optimal services. For more information about usage of these parameters, see issue 07 of the G.fast series or the G.fast Access Special topic.